Hello everyone. We're going to continue with section 7.4. In this video, we will discuss the learning objective, explain the concept of resonance, and draw Lewis structures representing resonance forms for a given molecule. So let's go ahead and get started on that. So one of the things you may have noticed with doing some examples of formal charge is that there are some cases in which even though you've gone through the process of assigning formal charge, there is actually still more than one thing that are equivalent. And in fact, um, by equivalent, we mean that they are equivalent down to the level of the elements that make up the compound. So here's a great example of that. These are equivalent in terms of formal charge because you have oxygen without a double bond over here with a double bond over here. But they are not the same thing. These are different oxygen atoms. So the one on the left and the one on the right are different atoms. And here we're showing one with a single bond, and here we're showing that one with a double bond. So these are not the same thing. They're not showing the same thing. But when we look at these experimentally, what we see is that they are the same thing. So we're showing different Lewis structures that are basically incorrect. So neither one of these is actually correct. What's actually going on is a concept that we use the word resonance to describe. And the complete understanding of this sort of predates this way of showing it. And so some of the words, some of the way we represent this can be a little bit confusing. So when we talk about a molecule that has resonance, what we mean is essentially that the model of the Lewis structure is insufficient to describe that molecule. So everything we've been doing with Lewis structures fails to completely describe what's going on. And what's really going on is sort of like a mix of the two, but it's not that it's going back and forth, if that makes sense. So we're showing here the resonance structure for this thing. And how we show that is we show each of the possible Lewis structures that are equivalent and show this double arrow that is going between them. So the way we show it is actually a little bit misleading because it looks like we're saying we go back and forth from this one to this one. It's this one 1 minute, it's this one the next minute. And that's not actually what's going on. What's really going on is it's a mixture of both. The actual thing that's happening would be best viewed by taking both of these and putting them on top of each other, one on top of the other. And if you look down on it, what you really have is this bond is not a double bond and not a single bond, but somewhere in between. Likewise, this bond is not a double bond and not a single bond, but somewhere in between. And this concept is a little bit tricky to understand, but something we'll explore in greater detail when we get to Module 8. But there are some good examples of hybrid, this idea of a hybrid. So in your book, there's other ones that I've seen in other books. In your book, it's using this idea of rhinoceros being, not a dragon or a unicorn, but maybe some combination. So that was kind of a historical idea. The one I like to think of is related to fruit. So when I first moved to California, I heard about the pluot, which is neither a plum nor an apricot, but a mixture of the two. It's not as if you take one bite and it's a plum and the next bite it's an apricot. It's both at the same time. So that's when we talk about a resonance hybrid. That's what's actually going on. Here we're showing another example. In this one, we actually have 3 equivalent atoms. So in this structure, you would show arrows between the 3. So 3 resonance forms of this particular ion. Resonance comes up quite a bit when you have things that do form ions. So be aware of that. And you want to be able to draw correct resonance structures when that is possible. So that is the end of section 7.4.